Students, this is part 2, chapter 1, cubes and cube roots. Okay, this is part 2. Once again, I am repeating part 2, chapter 1, cubes and cube roots. And in part 1, one lesson that is constructions, one lesson I have not explained. So, due to some network issues, I am not able to explain many days. I think I have not explained, just I was sending notes, so sorry for that. And this is now I am explaining now part 2, cubes and cube roots, and that is constructions I will explain after this part 2 lessons. I will send videos of constructions. Okay, children? Okay, now let us see part 2, chapter 1, cubes and cube roots. Okay, so here cubes and cube roots. In previous class, that is in this class itself, that is 8th standard itself, in part 1 book, we studied squares and square roots. So now in part 2 we are studying cubes and cube roots. So like squares means like 4, like 2 2s are 4. The equal numbers are same numbers. When we multiply twice, then we'll get what? Square numbers. Okay. Similarly here, when we multiplied 3 numbers, 3 equal, the same numbers, 3 same numbers, then we'll get what? Cubes. Okay. For example, 2 into 2 into 2. Okay. 2 into 2 into 2 is how much? 8. 1 into 1 into 1 is 1. Okay. So that is nothing but 1. 1 into 1 into 1 is what? 1. That is nothing but how many times we multiplied? Thrice we multiplied. So 1 cube. We represent that as 1 cube. Okay. So like this. Now let us see what are cubic numbers or perfect cube numbers. See 1, 8, 27 are perfect cube numbers. So 1, how we got? 1 into 1 into 1 is 1. 2 into 2 into 2 is 8. 3 into 3 into 3 is 27. So these numbers, many numbers are there. Like next 4. 4 into 4 into 4 is 64. Yes or no? 4 4 is 16. 16 4s are 64. So 64 is also a cubic number. Okay. So such numbers are called what? Perfect cube numbers. Okay. Now each of them is obtained when a number is multiplied by taking it in how many times? 3 times. Like you can see here, just now I told. Okay. So 8 is equal to 2 into 2 into 2 is equals to 2 cube. 1 is equals to 1 into 1 into 1 is equals to 1 cube. Now 27, 3 into 3 into 3 is 3 cube. Okay, 3 cube. I am reading like this. See children, observe this one. Listen carefully. 3 to the power 3. 1 to the power 3. 2 to the power 3. Or else we can say 2 cube, 1 cube, 3 cube. Okay. Like in the squares, how we were reading? Like 4 square, 6 square. That means what? 4 to the power 2, 6 to the power 2. Like that. Okay, children. So these are what? Cubic numbers. Okay. 8, 1, 27, 64. Many numbers are there. I'll tell you. Okay. I'll tell you. You can see here some many cubic numbers here. You can see here. These are the numbers. For these numbers I have written here cubic numbers. That is cube numbers. Okay. 1 cube is what? 1 you have to multiply how many times? 1 into 1 into 1. So 1. 2 into 2 into 2 is 8. So like that. 3 cube is what? 27. 4 cube is called, is 64. 5 cube. Can you find out? 5 into 5 into 5. Multiply and write here. 6 into 6 into 6. Multiply and write here. Like that. All these, that means cubic numbers you will get here when you multiply. So please do this work. Okay. In your class work. Next is another one like 11, 12, 13 and all. Okay. So here we are having 11 is what? 1331. How we got 11 cube is equals to 1331. So when you multiply 11 3 times, 3 times in that means what? 11 into 3. It is not 11 into 3. It is wrong. Okay, 11 you have to multiply how many times? 11 cube. In the sense 11 into 11. Okay, if you multiply like this, you will get the answer 1331. Okay, similarly 12 cube is what? 7728. So like this you will get the cubic numbers. Now one more thing you can observe here, children. You all know what are even numbers and odd numbers. Okay, odd numbers are like 1, 3, 5, 7, okay, 9, 11, 13. All these numbers are what? Odd numbers. Okay, and then even numbers. What are even numbers? 2, 4, 6. 2, 4, 6, 8, 10, 12, etc. Many numbers are there. Okay, and why I am saying even numbers and odd numbers means, here you can see the numbers which are odd. See here 1, 3, 5, 7, 9. You can observe here odd numbers. Cubic numbers are also odd. You can observe here. See 1, 27 odd number. For 3 is odd number. 27 is odd number. 5 is odd number. Then you will get here also odd number. So here you can observe here also 11. See, it is an odd number. And 1331 is an odd number. So like that, when you find out cubic numbers for the given odd numbers, you will get cubic numbers are also odd numbers. Okay, children? And even numbers, when you multiply, when you find out for even numbers cubic numbers, then you will get that cubic number is also even numbers. This is always true, children. Okay, odd numbers, when you find out cubic numbers, that cubic numbers are all what? Odd numbers. Odd cubic numbers you will get. Understanding? Even cubic numbers you will get from even numbers. Understood? So this is what you have to observe here. In the higher classes you may utilize this concept. Okay, children? Okay, now let us see next page what you have. Okay, here see, here you can see cube of even numbers or even cubes. Okay, cube of even numbers or cubes. Sorry, even cubes. Cube of odd numbers or odd cubes. Okay, now let us see some of the peculiar characters we can see in cubic numbers. Like in square numbers, I explained some characters, that means some different the characters we can see here. So here also we can see peculiar properties. Okay, now adding consecutive odd numbers, you will get what? Cubic number. So how? See, let us see here 1. Okay, 1 I have taken here. 1 is an odd number. Okay, 1 is equals to 1 is equals to what? 1 cube. Correct? Odd number again. Now 3 plus 5 is equals to what? 8. Odd numbers. When you add the next consecutive, what is the meaning of consecutive? The continuous numbers, the next odd numbers. Okay, 1 after 3 plus 5, then 7, 9, 11, like that. So here 3 plus 5 is what? 8, that is 2 cube. 7 plus 9 plus 11 is 27, 3 cube. Then 13 plus 15 plus, say how we are getting 13 after 11? 13. 13 plus 15 plus 17 plus 19. So here we are increasing one number in each step. Okay. Now this is 64, that is 4 cube. Now 21 after 19, next odd number is 21, isn't it? So 21 plus 23 plus 25 plus 27 plus 29 is equals to 125, that is equals to 5 cube. Okay, children, this is what the property you can see, like when you are adding consecutive odd numbers, then you will get what? cubic numbers. So you can continue this. After 29 is what? 31 plus 33, like that. So you will get next cubic number. Okay. Now next let us go to the example 1. Okay. Here example 1 is 4243, a perfect cube. 243. What you have to do? How to find out? Is 243 a perfect cube? How to find out? By prime factorization. Okay. 243. From 3 divide this one. Okay. Or factorize. 3 8s are 24. 3 1s are 3. Okay. 3 2s are 6. 2 remains. 3 7s are 21. Then 3 9s are 27. 3 3s are 9. Okay. So this is called prime factorization. So we got all prime numbers here. 3 into 3 into 3 into 3 into 3. So write this here. So here 3 into 3 into 3. When you multiply same number thrice, then only you will get a what is that, cubic number, isn't it? But here one set of cubic number we got. But the next step you can see. Okay. The next set is 3 into 3. So another 3 is missing. Okay, that means another 3 is missing, in the sense 243 is not a perfect cube. So how much is missing here? 3 is missing. If you multiply 3 here, it will become cubic number. Just in this question, what they have asked? They have asked us to find out whether it is a perfect cube or not. So it is not a perfect cube. That's it. If they ask you to find out which is the perfect cube is missing and how much is missing, all those things, then you have to write here 3 and you can divide or multiply something. Then you can make this as a cubic number. Okay, children? So that we'll see in the next problems. Okay. Now let us see next example. Is 392 a perfect cube? We have to find out that. If not, find the smallest natural number by which 392 must be multiplied so that the product is a perfect cube. Okay, now see here. First in example 1, what we did? We found out whether 243 is a perfect cube. Just they asked that one. But next question we have to find out, is this that is 392 a perfect cube or not? And after finding what is the smallest natural number is to be multiplied to make it a perfect cube. Okay. So now let us see the same procedure in example 1, how we did. 392 factorize. Okay. After factorizing, we got 2 into 2 into 2 into 7 into 7. So here 2 into 2 into 2, it has a set. Okay. And 7 into 7, there is no set. So how much is missing here? 7 is missing. Yes or no, children? Now, therefore, 392 is not a perfect cube. Okay. So, how much is missing? 7 is missing. So, both sides you have to multiply. Both sides you have to multiply 7. Okay. Here also 7. So, multiply. You will get, after multiplying, 2744 is a perfect cube. Okay, children? Now let us move to example 3. Is 53, that is 53,240 a perfect cube? If not, then by which smallest natural number should 53,240 be divided so the quotient is a perfect cube? Okay. Now 53,240 is equals to, you have to factorize. See here, you can see how to factorize here. Okay. So here 2 2s are 4, 1 remains, 2 6s are 12. Okay, 1 remains. Then again 12 is there, 2 6s are 12. Okay, then 4 is there, 2 2s are 4, then 0 as it is. Next 2 1s are 2, 2 3s are 6, 2 3s are 6, 2 1s are 2, 0 as it is. Then again 13, that is 1 3 3 1 0 is there, 13, 2 6 are 12, 1, 2 6 are 12, 1, 2 5s are 10, again 1 is there, 10, 2 5s are 10. Now this 6655 is divisible by 11, isn't it? 11 6 it is not dividing, that is 0. Then 11 5s are 55. Then 11 5s are again 55. 5 remains. 11 5s are 55. Again 11 5s are. Okay. Now it is, see here, 5 you got. 2 has set. 11 has set 3 times. And then 5 is there. Okay. Only 1 5. But here how much is missing? 5 into 5 is missing. Okay, should be divided. It is given divided. Divided in the sense you have to divide 5. If you remove 5, if you divide the whole thing, both the sides, 5, then you will get a perfect cube. So how to divide? You can see here. Have you got this? This should be divided by 5. And this is also divided by 5. So here actually this is not correct. Divided by 5. Okay. This 5 will get cancelled. And again here 5 will get cancelled. How much you get? 5 1s are 5. 0. 5 6 are 30. Then 5 4s are 20. 5 8s are 40. So 10,648 is the perfect square. Perfect cube. You can check it if you want. Again you can factorize, then you will get till here only 11. Okay children, let us move to example 4. Is 1188 a perfect cube? If not, by which smallest natural number should this be divided so that the quotient is a perfect cube? Similar way, you can see here factorizing. Then here you got 11. Then only 11 you have. Okay, so that means here 11 and here 2, only twice is there 2. That is, it is not a perfect cube. So how much you have to divide? This 2 into 2 you have to divide. You have to remove that. And then 11 also you have to remove. How to remove? Divided by 2 into 2 into 11. If you divide both the side, you have to divide. Okay, 2 into 2 into 11. Then after simplifying you will get 27 is equals to 3 into 3 into 3, that is equals to 3 cube. Okay, hence the smallest natural number is 2 into 2 into 11. Okay, that is the 44. Okay, from this we divided this one. Okay, next is example 5. Example 5 is 68,600 a perfect cube? If not, find the smallest number by which 68,600 must be multiplied to get a perfect cube. Okay, so then factorize this one. If you factorize, here 5 is missing. Okay, here 5 into 5 is there. Another 5 we didn't get, so it is not a perfect cube. So this should be multiplied. Here they asked us to multiply. So how much you have to multiply to get? So you have to multiply 5 both the sides. If you multiply 5, then you will get a perfect cube. Then after multiplying you will get 3,43,000 is a perfect cube. Okay children, next let us move to the exercise 1.1. Exercise 1.1. Which of the following are not perfect cubes? First one, 216. 216. So what you have to do? Not perfect. Following are not perfect. To decide whether the given numbers are perfect cube or not. So just now we see we learnt in examples. Once again I'm going to repeat this. First one, factorize. Okay, then after factorizing 216 you will get like this. Okay, 2 into 2 into 2 into 3 into 3 into 3, then 2 cube into 3 cube. So therefore 216 is a perfect cube since we have two sets, perfect sets. Okay, so it is a cubic number or perfect cube. Now next, fifth one I have solved here. 46,656 factorize. When you factorize, then only you will come to know whether it is a perfect cube or not. Okay children, that is why to factorize. Okay, like this 2 into you got like this. Okay, so here itself I have written, because so many numbers are there here, so therefore here itself 2 into 2 into 2 is nothing but 2 cube. Understanding, children? Then 2 into next set, 2 into 2 into 2 is 2 cube, 3 into 3 into 3 is 3 cube, 3 into 3 into 3 is 3 cube. So here 2 cube into 3 cube into 3 cube into one more 2 is missing, so 2 cube. Okay, 2 cube into 2 cube into 3 cube into 3 cube. Okay, so therefore see, all has set. Understood? Perfect cubes we have. So therefore 46,656 is a perfect cube. Okay, now please do this homework in a homework notebook. The problems are 128,000 and 100. Now next, second main, find the smallest number by which each of the following numbers must be multiplied to obtain a perfect cube. So fifth one I have explained here, 100 it is, 100, fifth problem is 100. So factorize, 2 2s are 4, 4 5s are 20, 25 is 100. Okay, so here 2 into 2 is there, but we need 2 into 2 into 2, 5 into 5 into 5. So that is 2 and 5 is missing. So that you have to multiply here. 100 into 2 into 2 is how much? 1000. 5 2s are 10, 10 into 100 is 1000. So here 2 you have added. So 1000 is equal to 2 cube into 5 cube. So please do this homework in your homework notebook. Then third main, find the smallest number by which each of the following numbers must be divided to obtain perfect cube. Okay, so fifth one I have chosen here, question 704. Factorize, again factorize. Okay, so here divided, they have asked us to divide. Okay, only 11 is there, so that is you have to divide by 11. So divide by 11, divide by 11. So simplify this, you will get 64 is equals to 2 cube into 2 cube. Okay, so please do this homework. 4 problems are there, please do in a homework notebook. The next fourth question is, Parikshit makes a cuboid of plasticine. Okay, plasticine of sides 5 centimeter, 2 centimeter, 5 centimeter. How many such cuboids will he need to obtain form a cube? Okay, so 5 centimeter, 2 centimeter, 5 centimeter. So here 5 into 5, okay, into what is missing? 5 is missing. Okay, 2 into 2 is missing, 2 is missing. So 5 cube into 2 cube. We need this 5 and twice 2 we need. Okay, now 5 into this 5 into 2 into 2 is equals to how much? 20. So 5 2s are 10, 10 2s are 20. 20 cuboids he needs to form a cube. Okay, this is what exercise 1.1. Now next is cube roots. I will explain that in a next video. Okay, thank you children.